Assalamu alaikum everyone. I'm Dr. Mohsen from KFUIT Rahim Yar Khan. Today we are going to discuss more about the electromagnetic spectrum and its surface interaction in the topic or the chapter of remote sensing. Division of the electromagnetic spectrum. Major division of the electromagnetic spectrum are arbitrarily defined. In a full spectrum of solar energy, there are no sharp breaks at divisions. Subdivisions are established for convenience and by traditions within different disciplines. This is the electromagnetic spectrum division, as the visible spectrum is we learn from zero point 0.4 to zero point 0.7 micrometer. Ultraviolet is on the left side, then X-rays, near infrared, thermal, microwave, radar, radio, and the TV wavelengths are presented towards the right side. Ultraviolet spectrum, UV has the shortest wavelength, which are particular for remote sensing. UV region is subdivided into near ultraviolet, UAVA 0.3 to 2.4 micrometer, or for ultraviolet, UVB 0.3 to 0.28 micrometer, and extreme ultraviolet, UVC below 0.28 micrometer. Visible spectrum. Invisible spectrum is a very small portion of spectrum as described in the figure with the arrow, and we discussed in the previous slide. Visible wavelength cover a range from approximately 0.4 to zero point 0.7 micrometer. Color of an object is defined by color it reflects. Infrared spectrum. Wavelengths longer than the red portion of the visible spectrum are designated as the infrared region, 40 times as wide as the visible light spectrum. Two important categories can be recognized here: near infrared and far infrared. Near infrared behaves in a manner analogous to radiation in a visible spectrum. Remote sensing in the near infrared region can use films, filter, and camera with designs similar to those intended for use with visible light. And the picture presented is a false color near infrared photo. Far infrared consists of wavelength well beyond the visible. Far infrared radiation is emitted by Earth. In everyday language, the far infrared consists of a heat or thermal energy, and sometimes it is called as emitted infrared. Microwave energy. Longest wavelength commonly used in remote sensing are those from about 1 millimeter to 1 micrometer in wavelength. Shortest wavelength in this range have much in common with thermal energy of the far infrared. Longer wavelengths of microwave region merge into radio wavelength used for commercial broadcast. Interaction with the atmosphere. Solar radiation hits molecules and aerosols in the atmosphere, result in scattering, absorption, and refraction of radiation. What is scattering? Redirection of electromagnetic energy by particles suspended in atmosphere or by large molecules of atmosphere. Amount of scattering that occurs depends on the size of particles, particle abundance, wavelength of radiation, depth of atmosphere. What is scattering? The Mie scattering, relay scattering, and the pattern of the Mie scattering is presented here. These are the scattering pattern already discussed in undergrad courses. There's no need for further discussion. Effect of scattering. Radiation in blue and ultraviolet region usually not considered useful for remote sensing. Direct energy from outside the sensor's field of view decrease spatial detail recorded by the sensor, tend to make dark objects appear brighter and brighter objects appear darker. Refraction is the bending of light ray at the contact area between two media that transmit light. Occur in atmosphere as light passes through layer of varied clarity, humidity, and temperature. Absorption occur when atmosphere prevents or strongly attenuates transmission of radiation or its energy through the atmosphere. Energy acquired by atmosphere is subsequently radiated at longer wavelength, largely attributed to three gases: O3, CO2, H2O between 5.5 and 7.0 micrometer and above 27 micrometer. What is atmospheric window? Wavelengths that are relatively easily transmitted through the atmosphere are referred to as atmospheric windows. Atmospheric windows show which radiation types are transmitted to surface of Earth or vice versa. Interaction with surfaces. Recall that as electromagnetic energy reaches Earth's surface, it must be reflected, absorbed, or transmitted. Proportion accounted for by each process depends on nature of the surface, the wavelength of the energy, and the angle of illumination. Let's look at these in more detail. What is transmission? Transmission of radiation occurs when radiation passes through a substance without significant attenuation. Transmission of many material varies greatly with wavelengths. What is reflection? Reflection occurs when a ray of light is redirected as it strikes a non-transparent surface. Nature of the reflection depends on the size of surface irregularities, roughness or the smoothness in relation to wavelength of the radiation considered as depicted in the picture. Reflectance. For many applications of remote sensing, brightness of a surface is best represented as reflectance. Reflectance with capital R is expressed as the relative brightness of a surface as measured for a specific wavelength interval. Reflectance is equal to observed brightness over irradiance. What does all this mean? As electromagnetic energy reaches our surface, it must be reflected, absorbed, or transmitted. Proportion accounted for by each process depends on the nature of the surface, the wavelength of the energy, and the angle of illumination. Reflectance behavior of an object over various wavelengths is referred to as a spectral reflectance signature. However, due to the factor mentioned, remote sensing measurements do not always result in unique spectral responses. Thank you very much. If you have any question regarding this topic, I will answer during the lecture or after the lecture through the social media like WhatsApp group of this course or the remote sensing or the GS, or you can comment on the my YouTube channel, so I will also answer. Thank you very much.